Hello my friends, I really hope that you are doing great. Welcome to our today's class. It is our second lesson on a Form 2 mathematics topic which is called indices. So remember, in our previous class we did introduce the topic indices, whereby we stated the laws of indices and did some few examples. So this is just a continuation. So we are also looking at past cases equations. So we are going to start with example 5, which is also a past cases equation done in 1997, paper 2, question number 7. So it reads, find the value of m in the following equation. 1 over 27 power m multiplied by 81 power negative 1 is equals to 243. So the question is worth 3 marks. So if you look at the numbers given, 27, 81 and 243, these numbers can be expressed to a base of 3. Therefore, I'll start by looking at the factors of 243. So of course, the common factors, 1, I'm going to start with 3. So 243 over 3, of course, we are going to get 81. Then 81 over 3, you are going to get 27. 27 over 3, you are going to get 9. Then of course, 9 over 3, you are going to get 3. Then lastly, 3 into 3, you are going to get 1. So we are going to express the numbers that we need to use, that is 243, in terms of base 3. So this will be, so 343 is 3 power 1, 2, 3, 4, 5. So this is 3 to the power of 5. Then we also have 81 in the question. So 81 is 3 power 1, 2, 3, 4. So this is 3 to the power of 4. Then we also have 27 in the question. So 27 is 3 to the power of 1, 2, 3. So 3 power 3. So I'm going to substitute these particular values in my question. So I'm going to have 1 over 27 is 3 to the power of 3. So this will be 1 over 3 to the power of 3, which is 27. Then the whole thing is to the power of m. Then I'm going to multiply with 81 is 3 to the power of 4. So this will be 3 power 4. Then of course, outside I have a power of negative 1. Then this is equals to 243 is 3 power 5. So this is 3 to the power of 5. Then I'm going to open this bracket. That simply means that m will multiply, I will raise both the numerator and the denominator to the power of m. So this will be 1 to the power of m, then divided by 3 to the power of 3m. So the m is raised to the numerator and also on the denominator. Then multiplied by, if I open this bracket, I'm going to have 3 to the power of 4 times negative 1, I'll get negative 4. Then this is equals to 3 to the power of 5. Then we know that 1 power m is just 1. So 1 power any number, you simply get 1. So 1 power m is 1. Remember, if you take 1 power 1000, you'll get 1. 1 power million, you'll get 1. So 1 power m, 1 power any number, you are going to get 1. Then divided by 3 to the power of 3m, then multiplied by 3 to the power of negative 4. Then this is equal to 3 to the power of 5. Then from there, I'm also going to apply the laws of indices. Remember, we said that whenever you have 1 over a to the power of n, this is the same as saying a to the power of negative n. So similarly, 1 over 3 to the power of 3m is the same as saying 3 to the power of negative 3m. You simply negate the power. So this equation will actually become 1 over 3 power 3m will be 3 power negative 3. So this is 3 to the power of negative 3m. Then I continue with the equation multiplied by 3 to the power of negative 4. Then this is equal to 3 to the power of 5. Then remember, from the laws of indices, whenever you multiply, you add the powers. So this will be 3 to the power of negative 3m. Then I'm going to add negative 4. So whenever you multiply, if the bases are the same, you add the powers. So this will be equal to 3 to the power of 5. Then plus times minus, you are going to get minus. So this will be 3 to the power of negative 3m, plus minus, you are going to get minus 4. This is equals to 3 to the power of 5. Once you remain with one value, and one value that is on the right and the left hand side being to the same base, then you can actually drop the bases. So I'm going to drop base 3 so that I simply equate the powers. So the power is negative 3m, then minus 4 should be equal to the power on the right hand side is 5. Collecting the like terms, I'll have negative 3m being equal to 5 plus 4. So this is negative 3m, which is equals to positive 9. So the value of m will be equal to positive 9 divided by negative 3. Of course, the value of m will be negative 3. Then we look at our sixth example, which is also a past cases equation done in 1998, paper 2, question number 10. So it reads, given that p is equals 3 power y, express the equation 3 power 2y minus 1 plus 2 times 3 power y minus 1 is equals to 1 in terms of p. So I'm simply going to substitute. Where I have 3 power y, I'm going to substitute with p. But for me to obtain that, I need to apply the laws of indices, such that, remember that if you have a to the power of m, then you divide with a to the power of n. This should give you a to the power of m, then minus n. So similarly, 3, so now I have 3 to the power of 2y minus 1. It simply means that it was 3 to the power of 2y, then divided by 3 to the power of 1, so that when you divide, you subtract the powers. Then this second value here, it means it was, if it is 3, if this is 3 power y minus 1, it simply means on this other side, it was supposed to be 3 to the power of y, then divided by 3 to the power of 1. Then I'm going to substitute those values in this equation. So where I have 3 to the power of 2y minus 1, I'm going to substitute with this one here. So I'm going to have 3 power 2y, then divided by 3 power 1. Then I continue with the equation. So plus 2, then multiplied by into bracket 3 power y minus 1. I've expressed it this way. So this is 3 to the power of y, then divided by 3 power 1. So I'm doing this so that I can easily substitute the value of p that I have. So this will be equivalent to 1. This will be equal to 1. So I can still break this one down. Remember we said that a to the power of m into n is the same as saying a to the power of mn. Therefore 3 to the power of 2y is the same as saying 3 to the power of y, then into 2. Remember, you can also write it as 3 power 2, then you put the y outside. But I'm putting the y into bracket because I need to obtain 3 to the power of y, so that I can easily perform my substitutions. So substituting the values in this equation, I'm going to have, so this is 3 to the power of y, then of course into 2, which will be a squared, then divided by 3 power 1. 3 power 1 is the same as 3, so this is just divided by 3, then plus 2 multiplied by into bracket 3 power y, so this is 3 power y, then I divide with 3 power 1 is just 3, then this should be equal to 1. But I'm told that 3 power y I substitute with p, so this will be p, but because there's a square, so this will be p squared, then divided by 3, then of course plus 2 multiplied by into bracket, this will be p, then divided by 3, this should be equal to 1. So this can be rewritten as p squared divided by 3, then plus I can also rewrite this as 2 will multiply with p, so that I get 2p, then divided by 3, so the whole thing over 3, so this should be equal to 1. So you can clearly see that the LCM for this case is 3, so I'm going to multiply through by 3, so times 3 times 3, then also times 3, so 3 and 3 will cancel out, 3 and 3 will cancel out, so I remain with p squared, then plus 2p, is equals to 3. So this will be p squared then plus 2p minus 3 is equals to 0. So this is a quadratic. So we can look for we can compare it with ax squared plus bx then plus c is equals to 0, whereby the value of a will be 1. So you can clearly see a will be 1. The value of b will be 2. Then the value of c will be negative 3. So I'm going to find the product and of course the sum so that I solve for the unknown value of p. So my product will be the value of a c, which is equals to, my a is 1, then of course my value of c is negative 3. So the product is actually negative 3. Then the sum will be the value of b, which from my case the value of b is 2. So if you look at the two numbers, when you multiply you get negative 3, if you add you get 2. I believe you simply check the factors of 3. So by 3 I'm going to get 1. So the factors will simply be 3 and 1. So but I need to introduce a negative somewhere. So the numbers will be we have 3 and we also have 1. So I need a product of a sum of positive 2. So the only way I can obtain that is if I put a negative on 1. So that 3 plus minus 1, you're going to get 2. 3 times negative 1, you get negative 3. So if I rewrite this, I'm going to have p squared then plus 2. I simply substitute where I have b, I substitute with 3 minus 1, because 3 minus 1 you will get 2. So this is 3 minus 1. Then into bracket I continue with this equation. So we have p then minus 3 is equals to 0. So this will be p squared, then 3 times p you will get positive 3p, negative 1 times p you will get negative p, then minus 3 is equals to 0. Common factors, we have p, so this will be p into p then plus 3, then common factor negative 1, so this will be negative 1 into p plus 3, then this will be equal to 0. So this will be p minus 1, then I multiply with p plus 1. So this should be equal to 0. So it means either p minus 1 is equals to 0, which simply means that p will be 1, or this was p plus 3, so it's p minus 1, so this should be plus 3, p plus 3. So either p is 1 or p plus 3 is equals to 0, therefore the value of p will be negative 3. So but they wanted me to find the value of y. So we had said that p is equals to 3 to the power of y. So if you substitute p as negative 3, then it's not possible to solve for y. So the only possible way is if we substitute p being 1. So the value of p is 1, so 1 is equals to 3 power y. Then remember, a number to the power of 0 will give you 1. Therefore I can write 1 as 3 power 0, which should be equal to 3 power y, so that the value of y will actually be equal to 0. So that is the only possible value of y. Then we look at our 7th example, which tells us to simplify the square root of 2 power x times 5 power 2x divided by 2 power negative x. So it is also a past cases equation done in 1999, paper 2, question number 4. So for me to solve this, I need to combine a number of laws. So this should be equivalent to so I can rewrite this as I want to combine the common factors. So this is the same as saying the root of, so I want to combine 2 power x and 2 power negative x. So this is 2 to the power of x, then divided by 2 to the power of negative x, then of course I multiply with 5 to the power of 2x. So because these ones have the same bases, I can apply the laws of indices so that I get the root of, remember, if the bases are the same, whenever you divide you subtract the powers. So this will be 2 to the power of x minus x, then I multiply with 5 to the power of 2x. So this will be the root of 2 to the power of minus will give you plus, so this will be 2 to the power of 2x, then multiplied by 5 to the power of 2x. Then there is a law that we stated in the first lesson of this particular topic, whereby we said that whenever you have a, that is, if you have a to the power of m, then you multiply with a, you multiply with a different base. If you multiply with b to the power of the same power to b to the power of m, then this is the same as saying a power m. Then that is, you simply multiply a and b, then of course you factor out the power. This is the same as a multiplied by b, then to the power of m. Similarly, if I apply the same thing here, it means that 2 to the power of 2x multiplied by 5 to the power of 2x is the same as saying 2 multiplied by 5, then the whole thing to the power of 2x. But remember, there was a square root, so this will become the square root of, so this is going to give me the square root of, so I get the square root of 2 times 5, I'm going to get 10, so this is 10 to the power of 2x. Then remember, square root is the same as saying multiplying to the power of a half, so this is the same as saying 10 power 2x, then the whole thing raised to the power of a half. Square root is the same as raising to the power of a half, so this will be 10 to the power of 2x, then multiplied by 1 over 2. So the 2 and 2 will cancel out, so the answer will be 10 to the power of x as our final answer. Then we look at our 8th example, which is also a past case equation done in 1990 paper 2, question number 4. So it reads, solve for x in 5 power 2x minus 1 is equals to 12 to the power of x. Now for this case, it is not possible to put the numbers to a common base. Therefore, what we are going to do, we are going to introduce log to base 10 on both sides. So this is a concept which is taught in Form 3. So this is 5 to the power of 2x minus 1 should be equal to 12 to the power of x. So I'm going to introduce log to base 10 on this side and also log to base 10 on this other side. So from the laws of logarithm, we can take the power here, so this can be written as 2x minus 1, then into bracket the logarithm of 5, then is equals to x logarithm of 12. Then if I open this bracket, this is the same as saying 2x log 5, then minus 1, then log 5. I'm simply multiplying log 5 by the numbers in the bracket, so this is the same as saying x logarithm of 12. Then I collect the like terms, that is the ones having x, so I'll take this value to the other side, so that I get 2x log 5, 2x log 5. Then if it comes to the left hand side, it will be a minus, so minus x log 12 is equals to, when I take this to the right hand side, I'm going to actually get, it will be positive, so it will be positive 1, then logarithm of 5, positive 1 log 5, which is just log 5. So x is common, so if I factor out x, I'm going to have 2 multiplied by log 5, then minus log 12, because I factored out x. So this is equals to 1 times log 5, I'll just get log 5. Then I want to make x subject of the formula, therefore x will be equal to the logarithm of 5, then divided by 2 multiplied by log 5, then minus log 12. So this one can be computed on the calculator, so you exactly press this on your calculator, log 5, then divided by, open bracket, 2 multiplied by log 5, then minus the logarithm of 12. Press exactly this way on your calculator. So your calculator is going to give you, let me use my calculator here and see what I get. So I have the logarithm of 5, then I'm dividing by, open bracket, 2 times the logarithm of 5, then minus the logarithm of 12. So this is going to give me 2.19. So I'm getting my value of x as 2.19. Then of course I am expressing it to 4 significant figures, so I'll leave this one as 3. So that is how to behave for numbers which cannot be expressed to a similar base. Then we look at the 9th example, which is also a partial question done in 2000, paper 2, question number 12. So it reads, find the values of x which satisfy the equation 5 power 2x, then minus 6 5 power x plus 5 is equals to 0. So I'm going to start by breaking this part here. Remember, a to the power of m, then into n is the same as saying a to the power of mn. So if I apply this law here, I'm going to have 5 to the power of x, then I take the 2 outside, then minus 6 multiplied by 5 power x, then plus 5 is equals to 0. Now you can see that 5 power x is common, so I will let y to be equal to 5 power x, so that I substitute here. So I'm going to have y squared, then minus 6y, then plus 5 is equals to 0. So these are quadratic, so I look for product and sum. So I compare with ax squared, then plus bx plus c is equals to 0. So clearly the value of a will be the coefficient of y squared, which is 1. The value of b will be negative 6, then the value of c will be positive 5. So the product is usually the value of a multiplied by c, which will be 1, then c is 5. So the product will be 5. Then the sum will be the value of b, which is negative 6. Then we check the factors of 5. So 5 of course has only 2 factors. 5 into 5, 1. So the numbers are of course 5 and 1, but we need to introduce a negative somewhere. So the sum should give me, the product should give me 5, the sum should give me negative 6. So I'm introducing negatives on both, so that when you multiply negative negative you get plus 5, when you add you get negative 6. So I'm going to rewrite this. So I'm going to have y squared, then plus, where I have the value of b, which is negative 6, I simply substitute with negative 5, then minus 1, then I close the bracket, I simply continue. So I add y, then plus 5 is equals to 0. Plus 5 is equals to 0. So if I open this bracket, I'll have y squared minus 5y minus y, then plus 5. This one should be equal to 0. So common factor here is y. So this will be y into y. Then of course minus 5. Then I'm going to factor out negative 1, so that it helps me to interchange the sign, so that I get a positive y in the other bracket. So negative 1 over negative y will get positive y. Then of course minus 5 is equals to 0. Because 5 by negative 1 you'll get negative 5. So this is y minus 1, then into y minus 5. So this one is equals to 0. So it means that either y minus 1 is equals to 0. So this one implies that the value of y will be equal to 1, or it also implies that y minus 5 is equals to 0. Therefore the value of y will actually be equal to 5. But we had said let y be equal to, let y be equal to 5 power x. So because we have gotten the values of y, I'm going to substitute. Therefore 1 is equals to 5 power x. We know that 5 power 0 is 1. Any number to the power of 0 is 1. So 5 power x. So it means x will be equal to 0. Or similarly, we can also work with this. If y is equals 5 power x, it means the y is 5. So 5 is equals to 5 power x. 5 is the same as 5 power 1. So this will be 5 power x. If I pick the powers alone, it means x will be equal to 1. So either x is 0 or 1. So tomorrow we'll be continuing with more examples on the same. This is Kind Tuition Academy. Thank you very much.